Mean absolute deviation. Our goal is to calculate and compare the mean absolute deviation for sets of data. Mean absolute deviation is defined as the average distance the data points are from the mean. The purpose of the mean absolute deviation, it gives us an idea of how spread out a set of data is and how far the points are from the mean. The greater the mean absolute deviation, the more spread the data is from the average. The lower the mean absolute deviation, the less spread or smaller range there is in the data. Steps to find the mean absolute deviation. Step 1, find the mean of all the data points. A reminder how to find the mean: you add the numbers in the data set and you divide by the total amount of numbers in the data set. Step 2, find the distances between each data point and the mean. You're going to use the absolute value of each difference. Step 3, find the mean of the distances you just found. How to do that? Add the absolute differences and divide by the amount of numbers in the data set. So let's go ahead and try. Find the mean absolute deviation of the following set of numbers. So step 1 says we're going to add all of the numbers in our data set and divide by the number in our data set. So we're going to find the mean. Step 1, we're going to add all of these digits. So we add them up and we're going to get a total of 100. Then you're going to take that total and you're going to divide by how many numbers are in your data set. And there are a total of 5 numbers in our data set. That will give me 20. This is called my mean or my average. Step 2 is we're going to find the absolute value difference between our 20 and each number in our data set. So we're going to see what is the distance between 20 and 12. So we subtract that, you would get 12 minus 20 is negative 8. But we're taking the absolute value of negative 8, which means what is the distance from negative 8 to 0? That distance is 8. Then we're going to find 20 minus 20, which is 0. But we're finding the absolute value of 0. So how far away is 0? From 0, it's 0. Then we're going to find out 22. 22 minus 20 is absolute value of 2. That is 2 away from 0. So 2 is the distance. 16 minus 20 is negative 4. Negative 4 is 4 away from 0. And then finally, we have 30 minus 20, which is 10. And the absolute value of 10 is 10 away from 0. So now we found the distances. The next step we need to do is find the average of those distances. So what's the average distance away from the mean? So to find the average distance, we're going to add these numbers up and we get 24. And then we're going to divide it by how many numbers there are, which there are still a total of 5 numbers. So 24 divided by 5 is 4.8. So our mean absolute deviation is 4.8. That means on average, each number is approximately 4.8 away from 20. Or the mean absolute deviation means 4.8 on average away from 20, our mean. Okay, let's try the next one. The table shows the maximum speeds of 8 roller coasters. Determine the absolute value deviation of the set of data. So we're going to go back to step 1. Step 1 was find the total of all of our numbers in our data set. So we're going to take 58 plus 40 plus 72 plus 80 plus 88 plus 60 plus 66 plus 48. And that gives us a total of 512. And we're going to take 512 and we're going to divide it by the total number in our data set, which is 8. And that gives us 64. This is called my mean or my average. Now we're going to find the absolute difference between 64 and each number in our data set. So the first one, 58 minus 64, which is negative 6, and the absolute value of negative 6 is 6. Then we're going to do 40 minus 64, and that is 24. Negative 24's absolute value is positive 24. 72 minus 64 is absolute value of 8 is 8. 80 minus 64 is absolute value of 16, which is 16. 88 minus 64 is 24. Absolute value of 24 is 24. And then 60 minus 64 is negative 4. Absolute value of negative 4 is 4. And then 66 minus 64 is absolute value of 2, which is 2. And 48 minus 64 is negative 16. The absolute value of negative 16 is 16. So those are the distances from 0. So we found the distances. Now we need to find the average distance. So what is the average of those distances? So we're going to take 6 plus 24 plus 8 plus 16 plus 24 plus 4 plus 2 plus 16. That gives us a total of 100. So to find our mean absolute deviation, we're going to take our 100 and we're going to divide it by how many numbers are in our data set, which was 8, and that gives us 12.5. So our mean absolute deviation is 12.5. So in other words, each data set is approximately 12.5 away from the mean. The average distance each data value is from the mean is 12.5 miles per hour. Example 3. The table shows the temperature at 2 different times for 6 days. The mean absolute deviation for the temperatures at 2 p.m. is 5.33. So our mean absolute deviation, they've already calculated it for us, is 5.33. Find the mean absolute deviation for the temperatures at 10 a.m. So our temperatures at 10 a.m. are to the left on the table. So step 1, we need to find the average. So we're going to take 55 plus 61 plus 54 plus 54 plus 50 plus 59. That gives us 333. And then we're going to divide it by how many numbers are in our data set, which is 6. And that will give us our mean, which is 55.5. So now what we have to do is I have to take my mean and I need to find the absolute difference between the average and each data set. So 55 minus 55.5, the absolute value of that is negative 1/2. The absolute value of negative 1/2 is 1/2, or 0.5. Then we're going to do 61 minus 55.5. The absolute value of 5.5 is 5.5. Remember, we're not having any negative answers. So I've got 54 minus 55.5. The absolute value of negative 1.5 is 1.5. And this is obviously the same number, so the same distance. Got 50 minus 55.5, which is absolute value of negative 5.5 is positive 5.5. And lastly is 59 minus 55.5. Absolute value of 3.5 is 3.5. So those are the distances between the mean and each data point. We want to find the average distance. To find the average distance, we're going to find the average of those points we just found. So we're going to take 0.5 plus 5.5 plus 1.5 plus 1.5 plus 5.5 plus 3.5. That gives us 18. And then we're going to divide that by how many numbers are in our data set. which is 6. So our mean absolute deviation, our mean absolute deviation is 3. So on average, we are 3 away from the mean of 55.5. Example 4. Teachers are being trained to standardize the scores they give students' essays. The same essay was scored by 10 different teachers at the beginning and at the end of the training. At the beginning of the training, the teacher's mean absolute deviation was 3.7. Compare this to the mean absolute deviation at the end of the teacher's training. So, just to reiterate, at the beginning, the mean absolute deviation was 3.7. So, on average, the teachers were scoring about 3.7 away from the average score. So now they got some training so that they can be more consistent in how they calculate. Mean absolute deviation calculates your consistency. So we're going to do step 1. We're going to find the average. So we're going to take 79 plus 82 plus 84 plus 81 plus 77 plus 85 plus 82 plus 80 plus 78 plus 83. That has a total of 811. And we're going to divide it by how many numbers are in our data set. 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide that by 10. And that will give us our mean, 81.1. This is our mean, or our average. Now we want to see how far are the teachers grading from each other from the average. If the average score is a little over 81%, how well are the teachers grading compared to their peers? So we're going to take 79 minus 81.1, and the absolute value difference is positive 2.1. The next distance is 82 minus 81.1, and that is 0.9, which absolute value is 0.9. Then we're going to take 84 minus 81.1. That is the absolute value of 2.9 is 2.9. Then we're going to do 81 minus 81.1, which is negative zero point 0.1, but the absolute value is 0 0.1. 77 minus 81.1 is negative 4.1. The absolute value of negative 4.1 is positive 4.1. 85 minus 81.1 is absolute value of 3.9 is 3.9. 82 minus 81.1 is 0.9. Absolute value of 0.9 is 0.9. 80 minus 81.1 is negative 1.1. Absolute value of negative 1.1 is positive 1.1. 78 minus 81.1 is negative 3.1. The absolute value of negative 3.1 is positive 3.1. And 83 minus 81.1 is 1.9, and the absolute value of 1.9 is 1.9. These are the distances. Now we want to find the average of the distances, which is called, again, the mean absolute deviation. So we're going to take 2.1 and 0.9, 2.9, 0.1, 4.1, 3.9, 0.9, 1.1, 3.1, and 1.9. That gives me 21, and we're going to divide that by the number in our data set. And there are 10 numbers in our data set. So our mean absolute deviation is 2.1. So as you can see, if the average distance was 3.7 from the average, now the average distance is only 2.1, which means the teachers are being more consistent in their grading because they are all closer to the average. So they have improved their scores. Okay, and then last. Which of the following describes a situation in which the data set with a low mean absolute deviation is preferred? So, when do you want to have a small range of numbers? Well, at a car dealership, cars sell at different prices. B, a factory manufactures computers of different sizes and shapes. C, a food processing plant fills each can with the same amount of soup. Well, you want the data to be close to each other because you want consistency. Well, you're not going to have consistency when you have different cars at different prices. You're also not going to have consistency at a manufacturer that has different size computers. And you want to have each can that's filled with the same amount to be consistent. So when you buy a can of soup, if you buy one can of soup and the next can of soup, you want them all to have about the same exact amount of filling. Therefore, you want a low mean absolute deviation. You do not want your numbers spread out. You want them close together because they should be the same. All right, so from here, you're going to do your ed puzzle and then you will have your homework assignment.